Hello everyone, this is Dr. Kong from the Department of Computer Science at NDSU. In today's Virtual Lab 2, we will present some novel techniques in human-computer interaction. Human-computer interaction study the design and use of computer technology focus on the interface design between people and the computer. First, I would like to ask you a question. What devices are needed for a human to interact with a computer? I guess the first answer in your mind would be the mouse and the keyboard. Yes, mouse and keyboard are the most traditional interaction devices. However, with the faster development of sensing techniques, many new novel interaction devices and techniques has been developed recently. So in today's demo, my PhD student Tianyi will first present the lip motion, which uses the infrared camera to track hand movement and translate this detected hand movement to a computer command. Second, Tianyi will present the Myo Armband, which uses a novel EMG sensor. The EMG sensor measures electrical activity from the muscles to detect gestures made by a user's hand. So when the users are doing different gestures through the hand, the muscle will generate different patterns of electrical activities. So by detecting these electrical activities, the computer can translate these activities to a computer command. Next, Tianyi will demo the virtual reality technique, which is a pretty hot area recently. The virtual reality means the computer generates a simulation of a 3D image or environment that can be interact with in a seamless, real or physical way. Next, tabletop, which can simultaneously track 50 touch points, will be presented by Tianyi. Finally, Tianyi will present a mobile application that is funded by National Science Foundation. This mobile application focuses on providing preventive, proactive, and patient-centered care for the American Indian diabetes patients. Unlike many other diabetes self-management applications, this application specifically focuses on American India patients. So the application is customized for the American India patients by considering the unique, generic, social, economic, culture, ethic, and geographic characters of American Indians.
Hello everyone, my name is Tianyi and welcome to Professor Kang's Natural User Interaction Research Lab. Professor Kang and his research assistants, including me, we focus on research areas such as human-computer interactions. And in this lab, we have many very interesting and very innovative devices to help us exploring new, efficient ways of interactions. Today, I'd like to introduce you these devices and to show you how to operate them and share some ideas about these devices. Professor Kang and his students already written many papers based on these devices previously. And also today I'd like to introduce you a mobile application we just completed recently. And this mobile application is part of a NSF supported research project. The aim of this research project is going to help Native Americans, diabetes patients, and their providers.
This is the lip motion controller. It is an optical hand tracking module that uses air sensors to capture the movements of your hands with unparalleled accuracy. This is the app home that contains few showcases for its users. The controller uses two image sensors plus infrared LEDs. The LEDs illuminate your hands with infrared light. With object detection and recognition techniques, it can generate a virtual model of your hand movements. This is the Leap Motion Visualizer that shows what the device actually captured through the sensors and what is the actual model of your hand looks like. The air sensors not only capture high-accurate images, but also are able to capture objects in dark environments. The wide angle of the camera also provides enough space for users to wave their hands. This is a sample game provided by the controller home application. As you can see, the Leap Motion controller takes the advantage that allows users to interact with virtual objects with corresponding body movements. The Leap Motion controller could be very useful when interactions with virtual objects are needed, such as in a virtual reality environment. The device on my arm is called Myo Armband. It is a gesture control armband that consists of a band of 8 muscle sensors. You can see the software is recording the muscle signals from each muscle sensors. Hand gestures can be determined by analyzing muscle signals. The armband also has an accelerometer, a gyroscope, and a magnetometer for detecting arm motions. There are 5 predefined gestures that can be recognized by the armband. They are wave in, wave out, double tap, fist, and spread fingers. Muscle signals differ from one to another. In order to achieve higher accuracy, user can use their customized profile data. That is, the software generates a fitted pattern for the user, instead of using the universal data. The combination of hand gestures and arm motions allow users to complete a set of tasks. For example, to drag a drop-down menu and select one of the options. In this case, raising my arm triggers the menu, and spreading my fingers triggers the select action. More than that, the presentation mode allows users to use an armband during a presentation. User can show the pointer, zoom in, and zoom out. The presenter can simply switch slides by waving hand. This feature frees the presenter from the keyboards and controllers. Gesture-based interaction can be applied in almost all areas once a suited environment is created. The Oculus Gear VR is a portable VR device that can attach a Galaxy smartphone. The device is very easy to assemble and very easy to use. The virtual reality devices can create a pure virtual environment that can simulate experience similar to or completely different from real world. Virtual reality typically incorporates auditory and video feedback, but may also allow other types of sensory and force feedback. VR can serve many purposes such as training and teaching. Here is an sample VR scene. However, it is very difficult to share VR experience through videos. This is Microsoft Pixelsense Tabletop. It is powered by Microsoft Surface 2.0 software platform. It is similar to the Leap Motion controller, It has an infrared camera behind its screen, but this camera can detect any type of objects on the surface of the screen. So, people can interact with the device using direct touch interactions and by placing objects on the screen. As you can see, the camera can clearly detect any object's shape. Once the shape is defined, the computer can do further object recognition based on the shape. These patterns are developed by Microsoft. Objects of a specific size and shape, or with tag patterns, can be uniquely identified to initiate a pre-programmed response by the computer. Next, here are some examples about how the program can do with the predefined patterns. Here we have the visualizer. Different from the raw image, the visualizer doesn't show the camera view anymore. Instead, it shows data properties of the objects, such as the tap, position, and orientation of objects. It successfully recognized text and fingers. And even with a lot of fingers. Next, we have created a very simple program based on the characteristic of this device. People with a little training might be able to create a similar program in a few minutes. In this program, we define different tags as different inputs, and they can be easily passed to other users. More complex program can be implemented. This tabletop allows multiple users to work together within one platform and share their works. This is part of the diabetes self-management mobile app we developed recently. The app is still in the testing and debugging stage, but we are going to release it soon. This app can establish communications between diabetes patients and healthcare providers. The entire program has 4 different parts: the mobile app for the patient, a mobile app for providers, a database for storing all data, such as the USDA food database, and a server for all communications. Let's take a look at the patient's app. Each user should register an account to use the app. The app allows users to record and upload data, such as blood sugar readings. Before submitting, we need to fill all required fields. Once the data has been submitted, the provider can see it immediately. Users can also record and submit their data. We need to select specific foods for each data. Once we finish entering, the app provides calculated nutrition on the side for review. The mobile app also provides social functions such as messaging. The patient can message the provider at any time. The education section allows users to read medical tips and posts that posted by the provider. Once the provider sets a goal for the user should receive a notification immediately. Also, the user can update his profile. This is the provider's app, but you cannot log in with a patient account. The provider receives a notification because we just uploaded a blood sugar reading through the patient's app. And here we can view the details of the warning. Also, we received a message from the patient. The provider can view all the patients who's using the patient's app. And also, the provider can view the detail about the patient. The provider can also edit or post new medical tips and medical posts. Providers can advise or educate their patients by posting these tips and posts. Also, provider can search patients by filters. And this is a brief overview of two apps. And thanks for watching. I hope you enjoyed the video.